the examples in the miscellaneous exercise 6a. Now example number 11, find the value of lambda. Find the value of lambda so that the lines 1 minus x upon 3 is equal to 7y minus 14 upon 2 lambda is equal to z minus 3 upon 2, and 7 minus 7x upon 3 lambda is equal to y minus 5 upon 1 is equal to 6 minus z upon 5 are at right angle. Here these two lines are at right angle, that means these two lines are the perpendicular, and we know that when the two lines are the perpendicular, then the relation between their direction ratios, okay, the direction ratios of first line are a1 b1 c1 and direction ratios of second line are a2 b2 c2. Then the relation between the perpendicular lines, it is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Now first find the direction ratios of both lines. Okay, here given lines, it is 1 minus x upon 3 is equal to 7y minus 14 upon 2 lambda is equal to z minus 3 upon 2. It is equation number 1. Now direction ratios of the line, here 3, 2 lambda and 2, you know these real numbers are the direction ratios of the line. When the equation of line in the form x minus x1 upon a is equal to y minus y1 upon b and is equal to z minus z1 upon c, then the a, b, c are the direction ratios. Here 3, 2 lambda and 2 are the direction ratios, but compare carefully. Okay, here x minus x1, x, y and z, here variable x, y and z, their coefficient is 1. Okay, here the coefficient of x is minus 1, here coefficient of y is 7 and here it is coefficient of 1. Okay, now we convert this, it is a coefficient of x is into 1, therefore we can write this equation, see carefully, throughout multiply numerator and denominator by minus, therefore you can write minus, it is x minus 1 upon minus 3, see carefully, multiply by minus, it is minus and it is plus, x minus 1 upon minus 3 is equal to, here y we want to y, but here it is a 7, so divide the numerator and denominator by 7, we get y, therefore divide numerator and denominator by 7, therefore y minus 2 upon 2 lambda by 7, see carefully, and is equal to, here coefficient of z is 1, therefore there is no change. Now minus 3, 2 lambda upon 7 and 2 are the direction ratios of line, therefore its direction ratios are, it is a1, b1 and c1, minus 3, 2 lambda by 7 and 2. Okay, these are the direction ratios. Okay, these real numbers are not direction ratios of the line, because equation of line not in the form of this x minus x1 upon a, y minus y1 upon b and z minus z1 upon c. Now second line, and equation of line, it is 7 minus 7x upon 3 lambda is equal to y minus 5 upon 1 is equal to 6 minus z upon 5. Okay, it is equation number 2. Now here it is minus 7x, therefore divide numerator and denominator by minus 7, therefore we get it is x minus 1 upon minus 3 lambda by 7. See carefully, here we divide by minus 7, we want to plus x, it is a plus x. It is as it is. Y minus 5 upon 1, and here we multiply by minus. Z minus 6 upon minus 5. Okay, and its direction ratios are, it is A2, B2 and C2. It is minus 3 lambda by 7, 1 and minus 5. And we know that it is given line 1 and 2 are perpendicular. Okay, and therefore we can write here A1 A2 plus B1 B2 plus C1 C2 is equal to 0. A1 B1 C1 and it is A2 B2 C2. Therefore it is minus 3 into minus 3 lambda upon 7 A1 A2. Now B1 B2 plus 2 lambda by 7 into 1 plus 2 into minus 5 and equal to 0. Now calculate. Here 9 lambda upon 7 plus 2 lambda upon 7 and minus 10 is equal to 0. Now throughout multiplying by 7, therefore 9 lambda plus 2 lambda minus 70 is equal to 0, and then it is 11 lambda is equal to 70, and therefore lambda is equal to 70 upon 11. Okay, here see carefully this. Okay, here we use the condition of perpendicular line when direction ratios are given. Okay, condition is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Okay, now we see the next example. Next example, find example number 12. Find the acute angle between lines x minus 1 upon 1 is equal to y minus 2 upon minus 1 is equal to z minus 3 upon 2, and x minus 1 upon 2 is equal to y minus 2 upon 1 is equal to z minus 3 upon 1. Okay. Now we want to find the acute angle between lines. Here in the chapter vector we see the acute angle between vectors. And also we see when the given direction ratios of the vector, we find the acute angle between them. Okay, here direction ratios of line, it is 1 minus 1 2 a1 b1 c1 and a2 b2 c2. Then the acute angle, formula for the acute angle, it is cos theta is equal to mod of a1 a2 plus b1 b2 plus c1 c2 upon under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. It is a formula for the acute angle. And if the lines are perpendicular, then the condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0. We are already using the last example. Now first find the direction ratios of two lines. Here given lines, it is x minus 1 upon 1 is equal to y minus 2 upon minus 1 is equal to z minus 3 upon 2. Okay. Here its direction ratios are, its direction ratios here a1, b1 and c1, 1 minus 1 2, and second line it is x minus 1 upon 2, y minus 2 upon 1 and z minus 3 upon 1. It is equation number 2. Okay. Its direction ratios are, it is a2, b2 and c2, 2, 1 and 1. Okay. We know the direction ratios of both the lines. Let theta be acute angle between lines. Okay. Therefore, we know the formula. Cos theta is equal to mod of a1 a2 plus b1 b2 plus c1 c2 upon under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Okay, here it is a formula for the acute angle. Now put the all values and take the calculation. Here a1 a2, 1 into 2 plus minus 1 into 1 plus 2 into 1 whole to the upon under root of 1 square plus minus 1 square plus 2 square into 2 square plus 1 square and plus 1 square. Only put the value of a1 b1 c1 and a2 b2 c2. Okay. Now cos theta is equal to 2 minus 1 plus 2 upon here 1 plus 1 plus 4, it is under root 6 and it is also under root 6. Under root 6 into under root 6. See carefully the calculation. It is 2 minus 1 1. It is a 3 upon 6 and therefore cos theta is equal to 1 by 2. Okay, and then theta is equal to 1 by 2. It is a 60. Okay, that is pi by 3 or 60 degree. Okay, when we know the direction ratios of the line, okay, we find the acute angle between them. Okay, this example you are already learned in the chapter vector, 3-dimensional geometry, direction ratios and direction cosines. Okay, now next example. Next example is also same. Find the acute angle between lines. It is the 13th example. Find the acute angle between lines. X is equal to y and z equal to 0. See carefully. And x equal to 0 and z is equal to 0. Okay? These are the two lines. First line is x equal to y and z is equal to 0. Here given lines are x is equal to y and z is equal to 0. That means, see carefully, x upon 1 is equal to y upon 1 is equal to z upon 0. Okay, here direction ratio, it is a indeterminate form, but it is a direction ratio. Direction ratios of line 1. Therefore its direction ratios are. It is A1, B1 and C1. 1, 1, 0. And second line, x equal to 0 and z is equal to 0. See carefully. X equal to 0 and z is equal to 0. Here, these concepts we are learning in the chapter vector 3-dimensional geometry. Here, x equal to 0 and y is equal to 0. We will learn in 2 dimension. When x equal to 0, when x equal to 0, it is a y-axis. And when y equal to 0, it is a x-axis. Here, x equal to 0 and y is equal to 0. That means line is a y-axis. Okay, that is, line is y-axis. Line is a y-axis, and therefore direction ratios of y-axis are 0, 1, 0. That is A1, B1 and C1. We can write here. A2, B2 and C2. It is a 0, 1 and 0. See carefully. Okay, we can write clearly in the below the line. Direction ratios of y-axis are 0, 1 and 0. That means A2, B2, C2. It is A2, B2 and C2. Okay, and then we know the formula. It is A1, B1, C1 are the direction ratios of that line. And here it is x equal to 0 and y equal to 0. It is nothing but the y-axis. Okay, it is x equal to 0 and y equal to 0. It is a y-axis. X is equal to 0 and z is equal to 0. It is the equation of y-axis. And the direction ratios of y-axis are 0, 1, 0. Then here put the all values. A1, it is 1 into 0 plus 1 into 1 plus 0 into 0 upon under root of 1 square plus 1 square, okay, plus 0 square into under root of 0 square plus 1 square plus 0 square. Now calculate. Therefore cos theta is equal to 0 plus 1 plus 0 upon under root of 2 into under root of 1, and therefore it is 1 by under root 2. Cos theta is equal to 1 by under root 2, and therefore theta is equal to 45 degree, or it is a pi by 4. Okay. Here direction ratios of this line 1, 1 and 0, and x equal to 0 and z is equal to 0. Equation of line, it is x is equal to 0 and z is equal to 0. It is equation of y-axis. Okay, in a 2 dimension, when x equal to 0, it is equation of y-axis, and when y equal to 0, it is equation of x-axis. In 3 dimension, when x equal to 0, y equal to 0, it is a equation of, when x equal to 0, z equal to 0, it is equation of y-axis. When x equal to 0, y equal to 0, it is equation of z-axis, and when y and z are 0, it is equation of x-axis. Okay, therefore are the direction ratios of this. Now next is the same example, only change the here. It is a minus 1. It is a minus y. Okay, here it is a number 14 example. See carefully. Only change in x is equal to minus y. X is equal to minus y. That means this type and such type equation, it is minus 1. Okay, same calculation, only here it is a minus. Here it is a minus 1. Okay, and then calculation is same, only here minus 1. Therefore it is minus, and it is mod this, and angle is same. Question number 13 and 14 is the same. Okay, now we see the next question. It is the question number 15. Next, find, next it is a 15th example, example number 15. Find the coordinates of the foot of perpendicular drawn from the point 0 to 3 to the line x plus 3 upon 5 y minus 1 upon 2 z plus 4 upon 3. Okay. Here, such type example we have already seen. Find the coordinates of foot of perpendicular. Okay. Here, it is a given line. X plus 3 upon 5, y minus 1 upon 2, and is equal to z plus 4 upon 3 is equal to, say, lambda. We want to find here the foot of perpendicular drawn from the point, it is a 0 to 3. Okay. Here we say it is a P. Okay. And line x plus 3 upon 5, y minus 1 upon 2, and z plus 4 upon 3. Okay. Here it is the equation of line. Now we want to find the coordinates of the foot of perpendicular. Say it is a Q. Okay. That Q lie on this line. That is a Q is a point on the given line. Okay. Then any point on the line, it is xyz. Then we take the xyz are the coordinates of the point Q, and then we know that it is a PQ and the line are the perpendicular. Then find the direction ratios of PQ. P is a given, Q we find, then Q is any point on this line. Then from these 2 points we will find the direction ratios of PQ, and direction ratios of given line are 5, 2 and 3. It is A1, B1, C1. It is A2, B2, C2, and both are the perpendicular. Therefore A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Okay. Here it is equation number 1. Its direction ratios. Okay. Here A1, B1 and C1, 5, 2 and 3 direction ratios of. Okay. Then any point on the line, and x plus 3 is equal to 5 lambda, y minus 1 is equal to 2 lambda, and z plus 4 is equal to 3 lambda. Therefore x is equal to minus 3 plus 5 lambda, y is equal to 1 plus 2 lambda, and z is equal to minus 4 plus 3 lambda. Therefore it is x, y and z is equal to minus 3 plus 5 lambda, 1 plus 2 lambda, and minus 4 plus 3 lambda. Be any point on line. Okay. Here we consider it is any point on line. We consider it is a foot of perpendicular drawn from the point 0 to 3. Let it is a Q, x comma y comma z be foot of perpendicular drawn from P, it is a given point 0, 2 and 3 to line 1. Okay. Therefore line and PQ are the perpendicular. The direction ratios of line are known. We find the direction ratios of PQ. Okay. Here it is a P and it is Q, Q x y z. It is the coordinate of point Q. Therefore direction ratios of PQ r. Here coordinate of p and it is coordinate of q. x2 minus x1, y2 minus y1 and z2 minus z1. That is -3 plus 5 lambda minus 0. 1 plus 2 lambda minus 2. And -4 plus 3 lambda minus 3 are the direction ratios of PQ. Therefore, A2, B2 and C2. It is -3 plus 5 lambda. 1 minus 2, it is -1. -1 plus 2 lambda. And last -4 minus 3 minus 7 plus 3 lambda. Okay. Here ABC, and we know that PQ perpendicular to line 1, and therefore we can write A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Therefore A1 B1 C1, it is 5 2 and 3. 5 into -3 plus 5 lambda plus 2 into -1 plus 2 lambda plus 3 into -7 plus 3 lambda is equal to 0. Then calculate -15 plus 25 lambda -2 plus 4 lambda minus 21 plus 9 lambda is equal to 0. Okay. Now 25 plus 4, it is a 29. Okay. 29 plus 9, it is 38. 38 lambda. And now here -15 minus 2, it is -17. -17 and -21 minus 38 is equal to 0. And therefore lambda is equal to 1. 38 lambda minus 38 is equal to 0. Lambda is equal to 1. And therefore coordinate of foot of perpendicular, it is a q. What is a q? -3 lambda, -3 plus 5 lambda, 1 plus 2 lambda and -4 plus 3 lambda. And therefore coordinates of q -3 plus 5, 1 plus 2 and -4 plus 3, because lambda is equal to 1. And then foot of perpendicular, coordinates of the foot of perpendicular 2, 3 and it is -1. Okay, here it is a coordinates of the foot of perpendicular. Okay, check this.